Chapter 4.4, Measures of Central Tendency. The measure of central tendency is also known as the measures of central location. The values are used to identify the center of the set data. These measures are the mean, median, and mode. First, let's have the mean. It is the most common measure of central location. To get the mean, all you have to do is get the sum of all the values of the observation divided by the number of observations. So we have the following formula. We use the symbol mu to indicate the population mean and the x bar to indicate the sample mean, where x is the observations in the sample or population and n is the total number of observation in the population or sample. So let's try example. Consider the following observations drawn from the population. Add 4.2, 5.0 until 4.8 and 5.1 divided by 7. Computing, so we have 37.1 divided by 7, which will give us 5.3. And that is our mean. So what are the characteristics of the mean? The mean is affected by the presence of extreme values. It is a good measure for interval and ratio type of data. So we cannot use the mean if we have qualitative data. Next, we have the median, which is the middle value of the set of observations arranged in increasing or decreasing order. It divides the data into half such that half of the observations fall below the median and the other half are above the median. So it's basically the middle value. To get the median, if you have an odd number of observations, so all you have to do is get the middle or half, which is n over 2. Now, if you have an even number of observations, that would mean that we have two values that are in the middle. So all we have to do is get the average of the two middle values, which is the n over 2 and the n over 2 plus 1, which is just beside the n over 2. Let's try this example. So first thing you have to do is arrange the numbers in order. We have 7 number of observation, which is odd. That would mean that our median is the n over 2 observation. So, solving, 7 divided by 2 is equal to 3.5. So, round it up or round it off. Our median would be the 4th observation. And the 4th observation would be the 4.8. So, our median is 4.8. Now, if we're going to compare, which is the more appropriate measure of central tendency between the two? If you look at the observation, our data are around 4 and 5. But there is one value that differs from the rest, which is 9. And this 9 is what we call our extreme value, which affects our mean. This extreme value would make our mean not a reliable measure of central tendency. So in this case, the most appropriate measure would be the median. The characteristic of the median, it is not affected by the presence of extreme observations. So it is the most appropriate measure if you have an ordinal type of data. Let's have another example for the median, which has an odd number, which has an even number of observation, like this one. 32, 40, 43, 37, and 9. Okay? So, of course, first thing that you have to do is arrange them in order. Okay? Now, we have a 6 number of observation, which is an even. That would mean when we get the median, we're going to get the average of the two middle observations. So, the median would be n over 2, which is 6 over 2. That would mean the 3rd and the 4th observation. 39 and 40. 39 plus 40 divided by 2, which is 39.5. And this is now our median. Mode is the value of the observation which occurs with the greatest frequency. So, ang pinakadaghan. Note, it is possible that a certain data has two modes. In such case, the distribution of the data set is called bimodal because we have two modes. When a certain data set has more than two modes, the distribution is called multimodal distribution. It is also possible that there is no mode in our data set. So let's have first example. So looking at the data, 9 occurs the most frequently, which is 3 times. So that would mean our mode here would be 9. This, we have 5, 5, 5, 5, 4 5s. And we also have 6, 6, 6, 6, 4, 6. Since the 5 and 6 tied in the number of frequencies, this would mean that our mode would be 5 and 6. Next, consider another set of data. 32, there's only 1, 40, 43, 37, 39, 45. There is no repetition of the data. So that would mean, in this case, we have no mode. Characteristics of the mode. Mode is determined by frequency. It is an appropriate measure for nominal data. Measures of variability, also known as measures of dispersion, is measured to find out how spread out or close the data values are. First, we have the range. The range is defined as the difference between the highest value and the lowest value in the data set. That would mean we simply subtract highest value minus the lowest value. Example, find the range of the following set of data. Here we have 11 as our lowest value and 21 as our highest value. So to solve for our range, we have 21 minus 11. That would give us 10. Looking at the value of the range, it's kinda quite spread. Next example, we have second set of data. Our lowest value is 14 and our highest, this is 14 is our lowest value and our highest value is 17. So to find our range, we have 17 minus 14. So our range is 3. So compared to the previous set of data, these data are somewhat more closer because the range is just 3 compared to the previous example, which is 10. The third one, so our lowest value here is 11 and our highest value is 20. So our range would be 20 minus 11. So our range is 9. It is still quite spread compared to the second. Next, for our measures of dispersion is variance. It is defined as the average of the square deviation from the mean. It is the measure that considers the position of each observation relative to the mean. So we are going to use the given formula where S squared is our variance, X sub I is our observation, X bar is of course our mean, and N is the number of observations. Then we have also the standard deviation, which is the most widely encountered. It is the measure of the spread or dispersions of the scores from the mean of the distribution. It is the square root of the variance. To illustrate variance and standard deviation, let's take this example. Once you get the mean, the actual height of the dogs are not actually equivalent to the mean. There is a difference from the actual height from the mean, which is this one. Okay, so the variance and the standard deviation would explain this deviation of their heights, of the actual heights from the mean. So the lower the value of your standard deviation and variance, the more consistent are the data sets. Example, find the variance of this first set of data. First, solve for the mean. Solving for the mean is you add and divide by 8. Then we get 15.5. We're going to use this value later on to solve for the variance and standard deviation. So we have the formula. So what you're going to do is, we're going to get the summation of the difference of each observation minus the mean. 18 minus 15.5, which is our mean, squared. And we also have 11 minus 15.5 squared, and so on. 6.25, 20.25, 6.25, and so on to 0.25. Adding all this, then it will give us a value of 78. So this is now our summation of x of I minus the mean squared that we will use to substitute in our formula. Substituting, we have 78 divided by 8 minus 1, since there are 8 observations. That would give us 11.14, our variance. Getting the square root of 11.14 will give us a 3.34, which is our standard deviation. Doing the same process, we also have the second data set. So solve for the mean. The second set of observation, we also have the same mean, which is 15.5. Solving for the variance, substituting the summation, which is 6 over 8 minus 1, that would give us a variance of 0.86 and a standard deviation of 0.93. Third set of observation, doing the same process, solve for the mean, which is 15.5, and then solving for the standard deviation, substituting the values that we get from the summation, that would lead us to a value of 20.85 as the variance and 4.56 standard deviation. To summarize the three sets of data, we have here ABC with the same means. So in order to differentiate the three sets of observation, we need to look at their variance and standard deviation. The data set B is more consistent because their variance and standard deviation is closer to 0. So if you look at the illustration here on the side, the data values are consistent. They are closer to one another. Unlike data set A and data set C, they are quite spread, okay, because they have bigger variance and standard deviation. So that's the purpose of measures of dispersion, in order to explain the consistency of our data values.